So in this video, I wanted to go over the results of predicting solubility. So I've gone ahead and filled in the names for all of these compounds right here. And the reason that I think it's important to know the name is that if you look at the rules for determining solubility, you'll notice that all of these rules are given as names rather than formulas. All right. So if you convert it to the name, you will be searching for the appropriate word. So in the first one, ammonium acetate, that compound could be determined to be soluble. All right, and what is the part of that that would let you know that it's soluble? All right, is that all nitrates, acetates, ammonium, and group 1A salts are soluble. That's the first rule. All right, you could have actually done this either the ammonium or the acetate. If either of those were to be present, it would have been soluble. In this case, you actually have both of them. For the next compound, iron 2 carbonate, well, the key word here is carbonate. And if you look at the rules here, there is a rule having to do with things that are insoluble, which is that all carbonates and phosphates except group 1A are insoluble. All right, so it's a carbonate, and it's not one of these exceptions, so it would be anticipated to be insoluble. The next example is sodium hydroxide. That would be anticipated to be soluble. And the reason for that is, if you look at the list here, things that tend to be soluble. Well, sodium, it begins with sodium, and anything that begins with a group 1A, a group 1 metal is going to be soluble. So if you hear sodium anything, you know that it's going to be soluble. All right. So by the way, when you did this, you were expected to give a reason. I'm just going to be pointing to the reason on the sheet. All right, so the next one, rubidium nitrate, that would be anticipated to be soluble. And the reason for that is, if you look at the first of these solubility rules, all nitrates are soluble. All right, so it can be blah, blah, blah nitrate. You automatically know that it's soluble. Cesium sulfate is going to be soluble. The reason that we would predict that it's going to be soluble, if we look down here at the bottom, all sulfates are assumed to be soluble except for these sulfates like calcium sulfate, strontium sulfate, barium sulfate, and cesium is not one of these exceptions. So you just go to the default rule, which is all sulfates are soluble. That's how you make the determination. All right, magnesium sulfate would be anticipated to be soluble for the same reason. All right, the next one, zinc hydroxide. Zinc hydroxide would be predicted to be insoluble, and the reason for that, when you look at what's a clue in that? All right, well, you know, there's nothing in this list that has anything to do with zinc, all right, but you do see something having to do with hydroxides, and it says that all hydroxides tend to be insoluble except group 1. Zinc is not in group 1, and it's not one of these right here. So you would go back to the default rule, which is all hydroxides are insoluble. All right, so that's why you would say that, predict that it is insoluble. Zinc phosphate, that would be predicted to be insoluble. The reason for that is that it is a phosphate. So all phosphates are assumed to be insoluble except for group 1 and ammonium. All right, and zinc is not part of these exceptions. So this rule right here, all phosphates would be assumed to be insoluble unless they're the group 1 or ammonium. All right, so the next one, silver bromide, would be predicted to be insoluble. The key part of this is bromide, all right? And if you look through the list right here, it says that, at first you might think, okay, it's soluble. It says that all chlorides, bromides, and iodides tend to be soluble, but then you look at the exceptions, except silver, all right, lead and mercury, all right. So it is one of the exceptions to that rule, all right. So it would be soluble if it was something other than these, but since it's silver bromide, it would be assumed not to be soluble, all right, which is insoluble, all right. The next one, aluminum nitrate, that is going to be soluble, all right, and the reason for that, it's a nitrate, all right. Anything nitrate is going to be soluble. That's the first rule on the solubility side. All right, strontium carbonate is going to be that is going to be insoluble. All right, and the reason for that is it is a carbonate. All right, and it's actually strontium is in group 2. All right, so it's not one of these exceptions. So you would go back to the default, which is that all carbonates are insoluble. So that's how we made that determination. All right. Potassium hydroxide would be predicted to be soluble. And the relevant thing, there's two ways that you could figure this out. First of all, is it begins with potassium, which is a group 1 metal, and all of those are soluble, right? You also could have looked at the term hydroxide in that, all right? And you could see all hydroxides are insoluble, which might make you think, oh no, maybe it's insoluble, but it's since potassium is in group 1, it's one of those exceptions. All right, so the potassium actually turns something which would ordinarily be insoluble into something that is soluble. Aluminum sulfide would be predicted to be insoluble. The reason for that is if you look down here, all sulfides except for groups 1 and 2 and ammonium. So aluminum is not part of that, so it would be assumed to be insoluble. Magnesium phosphate would be insoluble because it is a phosphate. And look at the exceptions here. What are we dealing with here? We are dealing with magnesium. All right, is magnesium one of these exceptions? No, magnesium's in group 2, so it would be assumed to be insoluble. Calcium acetate would be assumed to be soluble. That's the very first rule on the list, that all nitrates, acetates, and ammonium are soluble. So yeah, again, anything that ends in acetate would be considered soluble. All right, potassium sulfide would be considered to be soluble. And the reason for that is that it is a sulfide, but it's a group 1 sulfide. All right, so the fact that it has potassium in front of it is going to give it some water solubility. All right, you also could have just looked at the first rule that anything that starts with a group 1 metal is soluble and made the determination that way. All right, barium sulfate is going to be insoluble because you would originally look and see it's a sulfate, but which would tend to make it soluble, but let's look at the exceptions and you see the barium there. That's what makes it insoluble. So sodium sulfate, again, anything that starts with a group 1 metal is going to be soluble. So really, once you see sodium in the name, you don't have to go any farther. You know that it's going to be soluble. Ammonium cyanide is going to be soluble, all right? And again, applying that first rule, anything that starts with ammonium is going to be soluble. Barium chloride is going to be soluble. In this case, you're going to look at the chloride thing. All chlorides are soluble except for these ones that start with these metals. And since barium is not part of that, one of those metals, it's not one of the exceptions. So this would be assumed to be soluble. The last one, magnesium hydroxide, is going to be insoluble. Okay, by the way, magnesium hydroxide is actually, if you've ever heard of this medicine called milk of magnesia, and it's this chalky, it's like a liquid that's got this chalky substance in it, and that chalky substance is magnesium hydroxide. Um, and the reason it's chalky is that it's insoluble in water. All right, if it was soluble, it would be clear. All right, so how do we know this? We're going to look for hydroxides on this list. We see something about all hydroxides tend to be insoluble except for these right here. Magnesium is not one of those exceptions, so we could assume that it is insoluble. All right, so hopefully that helps. And what we're going to be doing is we're going to be applying these solubility rules to the double replacement reactions in the next part.